Alright, so this video is in case you missed Friday and you may not have understood Friday's lecture, and if you want to try to do the bonus on the take-home quiz. Alright, so this is a take-home quiz. Here's the one we did in class if you weren't here, and I'm going to work through this, okay? So, A right here. Derive it, then test it. So here's the derivative. I'm finding the critical points right up to the quadratic formula. Here's the quadratic formula. Alright. Except for I don't have my x equals. Let me change that. Alright. So here we go. I'm just going to go to my calculator and type those in. So 3 plus square root 129 divided by 6. .393. Okay, 2.393. Alright, good. X equals 2.393. And x equals, now I'll do my minus. Alright. Minus divided by 6, negative 1.393. Now we have to test. We'll use our sign chart. Okay. Our intervals are from negative infinity to infinity. So x is negative 1.393 and then 2.393, and we're going to test. Okay, I'm going to plug into the derivative, say negative 3, to see whether it's positive or negative, and then I'll plug in 0, see whether it's positive or negative, and then I'll plug in 3, see whether it's positive or negative into the derivative, y'all. So when I do this, well, I plug it into the derivative, and let's just do it kind of in our head right here. Negative 3 squared is 9, times 3 is 27, times this is positive 9, so positive 9 and 27 make 35. Alright. No, positive 9 and 27 make 36, positive, minus 10, 36 minus 10 is positive. So this is definitely a positive value, which means our function is increasing. We can include the interval as well, negative infinity to negative 1.393. And plug in 0, all you get left with is negative 10, or negative 20 in this case, 2 times negative 10. So it's definitely negative, or Kansas, and decreasing on this interval, negative 1.393 to 2.393. Okay, and I'm going to go ahead and assume, I don't like doing that. Well, when I plug in 3, let's double check. 3 times 3, 3 squared is 9, times 3 is 27, minus 3 times 3 is minus 9, so minus 9, 27 minus 9 is 18. Alright, and 18 minus 10 is positive 8, times 2 is positive 16, so yes, it's increasing. Alright, on the interval 2.393, all the way to infinity. Okay, so now we're done with A. Alright, so we know the graph is increasing up to this point. This is a, oh, I forgot. Always label your critical points as such. critical point, critical point. Alright, and we know these are maxima and minima. In fact, we know this is a max and we know this is a min. Alright, let's move on to the next step. So that's good. Now we want to do the second derivative and test. So, alright, f prime of x was 6x squared minus 6x minus 20. And so, doing the derivative to that, f double prime of x, 12x minus 6. Now we want to find the inflection points here, so we're going to set it equal to 0. 0 equals 12x minus 6. So when you solve this, x will eventually equal 1/2. Alright, so we're going to make our number line again. So we're doing a similar thing than what we did right here. Sorry. This is for increasing and decreasing. First derivative test. Also, it's to finding out where your velocity is positive and velocity is negative. Now we're going to do second derivative test, which is your concavity or acceleration. So your critical point is 1/2. Alright, yeah, in intervals are negative infinity to infinity. Alright, and let's go ahead and do it. So you got to test a point. I'm going to do f double prime of 0. F double prime of 0 is simply basically negative 6. Okay, so it's negative, or Kansas, which is decreasing. No, it's not. Alright, this is concave down, right? And this is where it's neither concave up nor down, which is called an inflection point. And if you test 1, you can see by the function that it's going to end up being positive. Alright, so that's concave up. Okay, so, and now we know our intervals of the concavity from negative infinity to 1/2. It's concave down from 1/2 to infinity. It's concave up. And there you go. The inflection point is 1/2. So we're done with step 2. Second derivative and test. Now we want to give the points of extrema. Alright? So, you know, this is a polynomial, so it's only going to have relative maxima and minima. So, we only need to worry about the critical points because the endpoints are negative infinity to infinity, so we can't do that. Alright? So let's get started on C. So we know that we have a relative max here. Alright, so let's find out where our relative max is and our relative min. Our relative max, we're going to plug in, hold on. F of negative 1.393. And we'll find out what that is. And our relative minimum, well, that's going to be a 2.343 because it's going from decreasing to increasing up here. So F of 2.34393. Sorry, my 9's look like 4's. Alright, so let's go ahead and substitute those into our calculator. Alright, so as you see, wait, that's a different function. I'll need that function later. So I'm going to unhighlight it. I'm going to go ahead and plug the function in, and I guess I need to see it. Alright, so the reason I'm doing this is much easier to plug it in your function and do the calculation instead of, it's so much easier. I'll show you. Alright, so 2x caret 3 minus 3x squared minus 20x. Okie dokie. So what I'm showing you is so much easier to do it this way. And let me see if I can zoom in. That'll be good for you. Just go second trace, yeah, second trace, calculate, and our values are, alright, second trace, I want a value, so I'm going to plug a value in for x after it gets done graphing. Okay, so what's my value for x? My values are, oops, my critical points are negative 1.393 and 2.393, I'll try to remember that. Alright, so, 0.393, 16.633. So 16.633 right there. And I'm going to do the other one real quick. I'm just doing the same thing, y'all. It's, yeah. It's just second trace again. Value. Okay. And then I'm doing 2.393. It's going to give me the answer pretty quick. Alright, so that's negative 37.633. It's funny how we're getting almost all the same decimals. Negative 37.633. So good deal. Alright, that's a relative max and a relative min. We're done with step C. Okay. Alright, so x and y intercepts are easy. X intercepts where y is equal to 0. Y intercepts is where x is equal to 0. Okay, so let's go ahead and do that real quick. Get my calculator out of the way. So, so start off with your x-intercepts. This is where y is equal to 0. So 0 equals, I'm forgetting what my original function is. Good thing it's in my calculator. 2x cubed minus 3x squared minus 20x. Alright, so 0 equals, alright, you factor out an x, so you end up with 2x squared minus 3x minus 20. Now a lot of y'all are having trouble with factoring. Y'all should be factor masters now. So I don't want to hear any excuses if I give you a problem like this on your test. X is equal to 0 is one of your factors. Now you have to find out where the other x-intercepts are. So what you got to do is, you know, these two factors. X is going to be one of your factors, but you've already solved for that, so it's all good. You know one of your x-intercepts is 0. So you're going to have a factor here and a factor here. Well, this could be 2x, this could be 1x. This could be 1x, this could be 2x. You only have basically one set of choices. So don't fool with this guy. It's a prime number, so put it in there first. You know? Because these guys, you're not gonna have to shift those around too much. Now on this one, this is more difficult because, you know, negative 20 has many factors. You know, it could be negative 1, 20, 20, negative 1. And this time order does matter because the negative 1 goes here and then the negative 1 goes here. So if you switch them, order does matter. And it also could be negative 2, you know, 10, and 10, negative 2, and negative 4, 5, 5, negative 4, you know, and that's it. You just got to choose the combination that works. And, you know, the combination that works is going to be the combination that when you multiply here, oh, that's not bright enough. When you multiply here, that's still not, when you multiply here and here, they add to give you negative 3. Okay? So you got to multiply here and then add to give you negative 3. So, for example, if I choose negative 1, negative 20, well, that makes negative 1 and negative 40. That doesn't add to give me that, so I need to get rid of those. Alright, so let's say I choose negative 2 and negative 10, because those other two weren't even close. Alright, that's negative 2, that's negative 20, that's negative 22. Oh, I'm sorry, negative 2 and positive 10. Should have been that way. So negative 2 and positive 10, that's not even close. That becomes positive 8. Alright, let's say we change, we use 5 and negative 4, positive 5 and negative 4. Well, 4 times 1 is negative 4, and 5 times 2 is 10. 10 minus 4 is positive 6. So we're getting a little closer, but we're still not there. Now, so since we're pretty close, let's just try flipping these. Okay. So let's say this is whatever the other one was. Let's say this is negative 5 and this is positive 4. Well, that's positive 8, and then negative 5, that's positive 3. Well, now we're very close. All we got to do now is switch the signs. Make it positive 5 and negative 4. Right? And then negative 8 and positive 5 give you negative 3. It's all guess and check. You're going to wear your eraser out. Alright, so I'm sorry I got off on a tangent there, but I think somebody might have needed to hear that. Alright, so let's move on. We found our factors. So 0 equals x, parentheses, 2x plus 5, parentheses, 1x minus 4, parentheses. So we know x is equal to 0. We know x is going to equal here to negative 5 over 2, because you're going to set it equal to 0. And a negative 5 over 2, I'll show this one. X minus 4 equals 0. Add 4 to both sides, x equals 4. So those are all your x-intercepts, guys. It's very easy. It's just guess and check for your factorization. Now, if you wanted to use the quadratic formula, you would get the right answer. You just don't forget to set this guy equal to 0 right here. Alright, so y-intercepts. Y-intercepts are easy. Make x 0. So plug in 0 for x right here. And that gives you 2 times 0 cubed minus 3 times 0 squared minus 20 times 0. So 0, 0, 0. Y-intercept is 0. Alright, so there you go. That's it for your x and y intercept. We're done with the fourth step. Alright, stay with me. If you don't need this one, if you need the next one, I'm going to post a separate YouTube video for the next one. So if you're waiting on the bonus type problems, then you're going to have to wait even longer. And they're not even on this video. Okay? So, alright, state the horizontal asymptote or slant asymptote. This does not have any. This does not have any vertical asymptotes. Alright, the domain of the function, easy. Alright, let's write it on our paper though. Alright, E and F, we'll put none. So, and I forgot to label, shame on me. X-intercepts. Alright, Y-intercepts. Okay, so E, none. F, none, and the domain G is negative infinity to infinity, or all real numbers. Alright, and now we need to make a sign chart and sketch the graph of the function. So, alright, we already have two sign charts over here, okay? Alright, we got a second derivative sign chart and a first derivative sign chart. You need to combine the two. Uh-oh. It's not what I wanted. Uh-oh. I was hoping maybe I could only highlight that, but it's impossible. Well, anyway, okay. Well, let's combine these two sign charts. I'll just try to remember. The important numbers are the critical points and the inflection point. Okay. And we're going to combine the intervals of increase and decrease with the intervals of concavity. So you're going to have, what you're going to have here, you're going to have overlapping intervals. so I'm going to show you, okay? Alright, so I'm going to make our super duper sign shot. If I can find the buttons. Where's the button at? Okay, well, I'll just try to draw a straight line. Okay, so positive infinity to negative infinity. Let's do my first derivative information first, but I have to include my inflection point. Alright? Uh-oh. There we go. So that was negative 1.393, and then I believe that was 2.393. I have to double check that. Yeah. Okay. And let's do our first derivative information first. It was increasing on this interval. Let me write it a little bit smaller because this is gonna increasing on this interval, and this interval is negative infinity to negative 1.393. And then it was decreasing on this whole interval, but now I have also the 1/2, so I'm going to include the 1/2. So negative 1.393 to 1/2. Alright, so we did the increasing, decreasing on this side of the 1/2. Now let's look at the concavity. If you look at your earlier concavity, it was concave down on the whole left side of 1/2. So we need to add that information in. Alright? So it's concave down on this interval, and also concave down on this interval. Right here. We've already listed the interval. Okay? Now let's write the other information for the first derivative. It was still decreasing on this interval. 1/2 to 2.393. Okay, but it was also concave up now. Sorry, my intervals are hard to see. Now it's concave up. Yeah, that's supposed to be in red. Alright. Yeah, we're good. Okay, and our graph was increasing to the right at 2.393 based on the sign chart above. So increasing 2.393 to infinity. Okay. And of course it was still concave up. Alright. Now, this information, along with our x-intercepts and our y-intercepts, alright, that's going to help us make the graph. Okay? Alright, so I'm going to slide some information down here. Oops. See if I can do this. Yeah. Oh, wow. And let's see if I can get my our extrema too are important. If I can find them. I don't know if okay. Alright. So I'll paste it down here. Where did it paste? Oh, I guess I have to drag it. I'm trying to use technology over here, guys. I'm sorry. Alright, so here, bringing down the relative max and min information. Alright. Alright, so bringing all that information down, now we can make the graph, okay? Now I'm just going to take the graph on the other page and kind of copy it over. Not really pasting where I want to paste, that's okay. I'll get it over there. Let's go now. Okay. Oh. Might help to get that out of the way. Alright. We're cooking with grease now. Alright. Alright, so important information we want to be able to have on our graph, okay, which I probably should have actually just kept it on the other page, but that's alright. Alright, so now we want to put the important information on the graph. I'll start with the relative max and min. It doesn't matter where you start. So here, negative 1.393. Alright, we're going to be up 16.6. So right there. And then 2.393. Alright, down 37.633. Which, I mean, I don't have to be down a whole bunch. There you go, that's about it. And then I want to do my x-intercepts too, so those are important. I'm going to cross the x-axis at 0. I'm going to cross the x-axis at negative 5/2, which is negative 2.5. And I'm going to cross the x-axis at 4. Okay, all important values. Alright, the other important value that I forgot was my inflection point. My inflection point's important too, that's 1/2. Okay, so somewhere around right here, I guess, 1/2, it's going to change from concave up to concave down. And now I just look at my sign chart. I know that I am concave down and increasing, then concave down and decreasing, and I know I have a, sorry, I still forgot, critical point, inflection point, critical point. I know I have a critical point there, so it's going to be a relative max or something. It's going to be a relative max. So I know I'm increasing. This is not going to look good, guys, so I'm sorry. Oh, Lord. Alright, let's see if I can do that better. Increasing. Oh. Decreasing. Oh. Then increasing. Alright. Man, I wish I could draw a smooth curve. Now, as you can see, increasing concave down, decreasing concave down. My inflection point's right here. That's where it should change from being concave down to concave up. But my graph doesn't say that because I'm a sloppy grapher. Alright, so this is it, guys. This is it for the lecture we did on Friday. So if you weren't here or you didn't understand, hopefully this helps, and good luck on your 2 take-home problems. Alright, peace.